I'm gonna go ahead and bring up. Wait a minute. All right, here's the questions and everything. All right, what are the 5 assumptions to check in order for the interference for simple linear regressions? How do we check them? Answer these by filling in the chart. So what I did was as simple as come on, is right.
The chart.
Yeah, right here, all of this. And how do you check it? You know, you just put your data into your scatter plot, making sure it's somewhat linear. Go to your Q plot, see if that works. The last 4 you don't know, but since they've collected the data, you can actually take it. And the constant variance is looking to see if it's no megaphone, so it's what is above that the variance line. And if it makes if the shape's on it makes a megaphone, then it's not. If it's nothing. But my question though is if any, do they have to have all of them though? I didn't know that.
No, I think so. For example, 1 is one chart. 2 is another chart.
Right.
3 is another chart. So it will only have 1. Like the linear relationship will be a scatter plot or residual plot. A hot dog shape or no pattern in the residuals.
Yeah.
Right?
Can you hold on? I gotta turn on the lights. Hold on.
That's fine.
You guys, I need you to be quiet, okay? All right. So, but it talks about, it's sort of like when we were doing the p-value. If pn equals, if it's more than 10, then it's good. And then, but you have to have both of them to equal. If one does not work, then it becomes, it doesn't, the data is null and void.
Yes, I think you're right.
So I think it needs all of them, but that's what it is. All right, going to the next question. Sorry.
Yeah, because it says if these requirements are met, then it is reasonable to assume that the use of regression with the data is I guess you're right, all of them.
Okay, I just want to make sure. All right, so what's that?
Nothing. Go ahead.
All right, number 2. What does all the things stand for? It's just
BO is the y-intercept and B1 is the slope, right?
Yep, and then the epsilon or E equals the error.
Yes.
So, okay. All right. So when doing so going into chapter part 3 of this, they did.
I have a chart for each thing.
Yeah.
There is a linear relationship between x and y. The error term E is normally distributed. The variance of the error term is constant.
Yeah, shake it up.
X's are fixed and measured without error. The observations are independent.
Okay, so it does pass all. It does pass all the assumptions.
Yes.
All right, so going into number 4A, then state the null. So am I correct that when in this class, all of them are, and when we're talking about inference for bivariate data, all are going to be implied as equal or not equal to 0. Is that what
I believe so.
Okay, makes sense. Okay. Let alpha be 0.05 for number B.
That's the answer.
Yeah. Okay. I didn't understand. Like, okay, that's the answer. All right. The test statistic on this is 22.675 based upon what I put into the actual Excel sheet.
Yes.
And the p-value is so minute that it's 5.005 e to the negative 13th, I think, or 8 or whatever. And then
we're rejecting the null.
Yep, reject the null.
And we have Sufficient evidence to suggest that there's a linear relationship.
Yep. And then we have, when we have the 95%, then it becomes 6.04 and 8.096 as your confidence intervals.
Yes.
I mean, I hope that's, I mean, that's, it's pretty much a lot of it is just as long as you put the data in correctly. And I found that with a homework assignment, it was sort of the same way. You just got to make sure you put it in right. So hopefully that will help. So, okay. Well, I think we're done. We can go stop for broadcast. Okay.
Sounds great.